Well, I think that we can start with the introduction, perhaps.
Okay.
Yes.
Very good. So I hope everyone hears me well. Uh, I would like to welcome everyone today. It's a very special edition of our civil engineering seminar series for 2021-2022 because we can welcome Professor Paul Ecke for the Royal Academy of Engineering Visiting Professor Inaugural Lecture. Professor Ecke is a visiting professor for the Royal Academy of Engineering here at our school at the University of Leeds, and is going soon to deliver his inaugural lecture on leveraging digital twin technology and systems engineering in delivering sustainable engineering solutions. In this lecture, Professor Ecke will present an integration of digital twin, systems engineering, and artificial intelligence technologies, and how these are going to change, and are changing already, engineering designs, engineering applications, with an emphasis on built environment that goes across all of our lives and also goes across the UN Sustainable Development Goals. For the ones who might not be familiar, Professor Paul Ecke is the Royal Academy of Engineering visiting professor in digital twin technology and systems engineering applications in engineering. He is an executive director of Preplan Limited. He has over 20 years experience in both academia and the engineering practice. He has a number of memberships of associations. He's UK Engineering Council Chartered Engineer, Chartered Environmentalist. You can see all the accolades that he has across the board and across the various organizations. He holds a Bachelor of Engineering in Chemical Engineering from Enugu State University of Science and Technology, an MSc in Oil and Gas Engineering from Robert Gordon University of Aberdeen, and a PhD in Civil and Environmental Engineering from the University of Edinburgh. He provides technical and commercial leadership. He contributes to learning by integrating more traditional techniques and delivers these modules in an industrial context to maximize the impact on students' learning. And he will introduce a specialist module on digital twin technology and the application to engineering to deliver solutions to global challenges. As part of this appointment at the University of Leeds, furthermore, Paul Ecke will also use his expertise to contribute to a wide range of activities and add value to the student experience. And all of it is certainly towards enhancing sustainable and innovative engineering practice. Join me in welcoming and thanking so much Paul for the lecture that I'm sure it will be very interesting, and in the end I will manage the Q&A session. Thank you.
Okay, thank you so much, Professor Prato, the head of School of Civil Engineering, University of Leeds, for such wonderful introduction. Okay, we'll get started with the topic of the day. This inaugural lecture that is titled Leveraging Digital Twin Technology and System Engineering in Delivering Sustainable Engineering Solution. We get the best part of it as we go on this lecture today. The abstract, which Professor Prato have gladly read, there's no need going on at that aspect again. In this inaugural lecture, my talk will focus on the introduction, very brief introduction, which Professor Prato have already done. I will go on the background of digital technology and system engineering. Then I continue with application in various fields with emphasis in infrastructure and wastewater engineering before making my closing remarks and give you all the participants time for question and answer. Introduction, as presented here, have already been covered. But one thing I need to point out is that life is a pursuit. And my own life for over 25 years has being dedicated in pursuit and channeling all those efforts towards providing professional services. I love technology development, so I have focused on developing and applying technology solutions that deliver beneficial impact in areas critical towards future. So why are we so much interested in digital twin? As worldwide demand for resources such as energy, water, and mineral rises in the face of climatic change, population growth, current coronavirus health crisis, and increasing environmental constraint, engineers, scientists, and resource managers crave for practical approach for providing sustainable solutions. It is already established that cutting-edge technologies are already reshaping our world. So in this inaugural lecture, I present to you digital twin, system engineering, and artificial intelligence application, and explain how they are providing sustainable engineering solution. If you may ask for those basic questions, what is digital twin? Just like every other twin, digital twin or digital replica, as some call it, is a visual model of physical assets. It's a model of product, process, system, or facility. Digital twin takes and uses data from actual system or assets. For example, engineers can identify safety risk of an aircraft by assessing temperatures and stress on different parts of the engine. Surgeons can navigate digital visualization of an organ before operating on patients. Digital twin of a rocket that displays maximum wind resistance can assure a launch in bad condition, and so many applications. So in detail, digital twin is most commonly defined as visual representation of physical assets, processes, people, places, systems, devices, designed to dictate, prevent, predict, optimize through real-time analytical, and deliver business values, and can be used in various purposes. The key piece of today's digital transformation is what digital twin is already forming. We use this to create and replicate various physical objects so that we could, in business world and in our life, boost productivity, streamline operations, increase profits. But we may trace the history of digital twin back to recent first time. Where did it come from? As you can see from the inside, digital twin was coined by Dr. Michael Gravis, University of Michigan in the year 202. He defined this as a replica, but this is not what the general world think where the origin come from. We believe digital twin have been used in the past when NASA put man on the moon, when they mirrored the aircraft, the rockets, they flew to the orbit. So in summary, you could see digital twin as a copy of physical asset or a dynamic digital asset, a visual representation of physical object, or you could just term it as the aspects of controlling what really exists. So how do digital twin works? Digital twin is powered by a combination of artificial intelligence, machine learning, advanced data analytics. Digital twin can mirror every physical twin you can ever think of and dictate, reveal issues before they occur. Digital twin rely on a range of sensors embedded in physical assets to transfer real-time data about the operative process and environment. For instance, as you could see here, every point where there is significant and important to replicate are always captured by sensors. We are aware that the fourth industrial revolution is already happening, and Internet of Things is surely an integral part of digital twin technology. From the definition given yet, it is clear that digital twin depends on and is an integral part of Internet of Things, driven by sensors, artificial intelligence, machine learning, data, and analytics. Internet of Things acts as a foundation for digital twins because it leverages data, physical assets, and now use this to make a better decision. It is important to point out that the impact and the usage are already happening. The IDC experts predicted that this year, digital twin will be adopted by almost 85% of Internet of Things platforms. But it's so important to note that recent data, January this year, indicates that digital twin adaptation already exceeded 85% prediction. Now we go straight to explain the background of system engineering. Systems engineering, which is part of digital twin, because digital twin is system of systems. So systems engineering is an interdisciplinary field of engineering and engineering management. It focuses on how you design, integrate, manage complex systems throughout their life cycles. So in a nutshell, its fundamental purpose is to realize successful systems and products. Successful here implies that the product satisfies the needs of customers, users, and all stakeholders. Now, we move on to digital twin application. Digital twin can be practically applied in every industry, any aspect in system, in process. Digital twin have been a very disruptive technology that provides a virtual representation of both elements and dynamic process or system. If implemented properly, have been influencing design, build, operation, and have been providing the real-time continuous calibration that transform to informed insight. In a nutshell, as Colin Paris, Vice President of Software in GE, puts it, digital twin is actually a living model that drives outcome. In general application, digital twin have seen its application in this major industry, major sectors like manufacturing, automobile, aerospace, healthcare, wind farm and renewable. Digital twin find its application virtually everywhere. In infrastructure, it's gaining momentum. Traditional oil and gas and other renewable energy sectors is also picking up very fast. In fact, if you break it down in recent research, indicates top practicing entities. General Electric and CEng, as you have seen here, is still leading by the number of patents in digital twin technology. Non-practicing entities like universities have also gained very massive application. For instance, back in America where this started, a lot of universities are receiving massive patents in various aspects of digital twin technologies, followed by individual inventors. If you break it down further, you could see that digital twin application and analysis indicate manufacturing as the area with the highest number of patents. The development is also followed by some other sectors like aerospace, automobile industry. They are really doing so well. Now, if you take a look at technical dissection of these two twin technology applications, You understand that area of testing, various design, various process and systems, using it to monitor assets and control assets like we have applied it in the North Sea, have also gained the highest aspect of technical usages. This followed by data processing area and other aspects of application. Now, in this lecture, we'll be mentioning significant impact of digital twin in infrastructure, because in civil engineering, this will be the major aspect. We'll be focusing on the development of this technology at Leeds. So as you can see here, in this picture, you will see digital twin is linking everything from communications satellites to various aspects of infrastructure and making life easy for digital twin to help us to plan, build, operate, monitor, and maintain infrastructure of different scales, right from building bridges, every single infrastructure. Engineers and manufacturers are gaining competitive advantage with digital twins. When we break down the application and infrastructure, specifically in the UK, we could see how massive the combination of digital twin and data is contributing so much in the UK economy. The recent publication from National Infrastructure Commission indicates that digital twin application and data now contributes around 50 billion pounds sterling to UK economy every year. It is in this point and the valuable use that we now recognize data virtually as digital gold or digital infrastructure. Infrastructure is not only physical these days. Data is one that is recognized as a digital infrastructure. Digital twin depends on data. Digital economy runs on data, irrespective of the challenges such as population growth, economic growth, climatic change, straining our infrastructure with the use of improved data and digital twin sharing across our sectors and assets. We can be sure of maintaining and planning our national infrastructure much, much better. The result we're seeing and the predictions of the application indicates that digital twin, artificial intelligence, machine learning could add over 10% to the UK economy by the year 2030. It is already amounting to about £2,300 per household in this economy. So digital twin, artificial intelligence, machine learning, and advanced analytics is established to help us in infrastructure extraction and utilizing vast amounts of information. Digital twin also, in infrastructure application, results available shows that it lowers consumers' bill. For instance, every £1 spent on water, smart meters provides returns up to £2.70 in offset of return on investment. It reduces impacts on environment, it reduces energy use, carbon emissions, and site visits where engineers normally need to be on site to dictate all the stuff. Digital twin and the data usage have already been established to improve transport. For example, it's predicted that digital twin and data application could save network rate up to £770 million over the next 8 years. Smart cities and other Internet of Things are becoming reality. Driverless cars and every other application is picking momentum. Construction industry, combining different aspects of digital twin, building information modeling, in 2014 is already contributing around £840 million. Now it is predicted that 8.9 billion direct benefits is attributed to data and digital twin in this country. So the proposal of the focus of this country is directed towards digital twin framework, digital twin infrastructure to help us plan, predict, and understand assets in this country, as we already kick-started in 2018 by forming Digital Twin Hub at University of Cambridge. So we focus these three aspects pointed out by National Infrastructure Commission. Our study here in University of Leeds, our direction throughout the tenure of my professorship will be focused on digital twin, application and digital twin learning, imparting the framework, the structures in Leeds and other collaborating entity outside this university. Now, moving forward to application of digital twin infrastructure, you can see the first application model have started. The framework the concept have moved away from theoretical aspects in this country to gradually targeting infrastructure, like in Bristol. It's ongoing using digital twin application in a transport within the city of Bristol. Throughout the tenureship of this professorship, we will be focusing so much in developing digital twins of water and wastewater to apply in all aspects of long-distance water pipeline and every facet of water and wastewater treatment plants, utilization from end to end back to every home within the circle of where we will map and start engaging students as we redefine and integrate digital twin concept in another stage of water and wastewater engineering. Several water companies are already adopting digital twin, as I earlier pointed out. The intelligent linking data from different sources and sensors, bringing all aspects of water delivery is moving forward and giving us opportunity to use water more effectively, more efficiently, and making it sustainable under the UN directives. How do we integrate digital twin in water industry? Digital twin have already helped us already in some application to tackle distribution challenges, reducing water losses through hydraulic controls and analyzing data available for the future use. The digital twin concept stimulates existing water supply network by generating all the scenarios, all the challenges for the future references. It helps the water authorities, as you have seen in the recent application, to develop consistent water supply at a very low implementation cost. It also brings transparency in various aspects of the operations to optimize processes. Digital twin have been huge in water, and we make sure we impart these transferable skills to our engineers as we integrate in the cost modules, existing traditional cost modules of water and wastewater design, and integration of other aspects of civil engineering like transport, structures, and so on. The application of digital twin in water industry have gained momentum worldwide, though a lot of challenges still remain with aging infrastructure, operators trying to meet customers' demand, but with digital twin technology and operational efficiency, the factors of achieving and taking water sector to another level is guaranteed, because digital twin can benefit both greenfield and brownfield, both water and wastewater plants. So in summary of water and wastewater application, digital twin bringing two concepts together, the virtual world and the real world, helps to integrate and improve performances. And that brings us to benefits of digital twins. Digital twin have massive benefits, but quickly, I'll just point out a few of them. Increased reliability and availability. We use it to monitor. In industry, we have massive records of gaining and saving so duch in infrastructure, running, using it to monitor and operate remotely. Most of the assets that during the past could not ever be harnessed. But with digital twin, the reliability and availability of such assets in remote areas like oil and gas sectors have been achieved. It reduces the risk, it protects the health and safety of employees in various harsh environments. It lowers maintenance costs because it predicts the use and breakdown of systems before they can even occur. With digital twin, improve different productions in factory in various ways. It also helps us for those who bring products to the market to make sure that this is delivered very fast. So in summary, we've used digital twin processes to save resources and control most of the area with this era of application of artificial intelligence. We are moving into saving in all aspects of our water and wastewater and every other infrastructure. Just to make sure that the coordination of the timing given so far will be within the area where few questions could be asked. I will take the concluding remark of this inaugural lecture, pointing out most of what the tenureship of my professorship will be looking at. Now, digital technology, not just digital twin. We know it very well that I've already changed how things are done. Within these years of my tenure, I'll be focusing on integrating this proven and tested technology into the engineers we'll be training in Leeds. We'll be applying this in designing, building, and various aspects of civil engineering. Because digital twin technology is vast and already established to have delivered in social and economic infrastructure, so we'll be focusing so much on application of this proven technology in infrastructure. Building information modeling is already transforming UK construction industry. So using information management process to gain efficiencies in design and construction process is already part of what this university teaches. And integration of digital twin here will enhance most of the existing module and also part of researches that will be developed and help to make Leeds the center of excellence in this very important technology. Over the next decade, this technology will combine both the BIM we combine with digital twin and Internet of Things as we move towards the fourth industrial revolution. Sensors, advanced data analytics, data-driven manufacturing, digital economy, all those things are the things we'll be applying in various parts of infrastructure to make sure our infrastructures are more effective, and we'll build it at lower cost, operate and maintain it for better performances over a longer lifespan. So towards these years I will be here, we will join with already established Digital Britain to seek from the aspect we could lay our hands from the university to large stakeholders outside the Leeds cities and Yorkshire Waters and any stakeholder that can partner with us to come up and form a kind of a hub so that the entire life cycle of this asset will find a ways of delivering more capacity within the existing infrastructure. So this part of the concluding remarks supports what the National Infrastructure Committee already bring out in the recent meeting. It supports new technologies such as digital twin to enable us to have better understanding of condition and performance of our assets. Digital twin, we've been using this as predictive maintenance. It helps in efficient operations and move on to save us as we move towards the net zero. It also helps in essential capture and analyze the right data. The regretted aspect of it is still work in progress, but with the help of National Digital Twin Strategy and the hub we envisage to establish within here, we'll be engaging deeply in this aspect of academia, and we recommend that we extend this to other professional learning providers, such as industry bodies and professional associations, so we can create a framework for digital twin skills development. In this concept, digital twin can be a tool for all our infrastructure assets and system process so that people, not only assets, digital twin is getting to another level where so many research areas are thinking about developing a digital twin of a moving soul of a human being so we can predict any aspect in the health sector, from the childbirth, capturing of the DNA, to diagnosis of ailments, cutting the treatment to another scale, the way we do already in infrastructure. So digital infrastructure innovations and associated in part of digital twin, self-driving autonomous operation using artificial intelligence, machine learning, automation. These things, these applications is already optimizing and tackling global changes in a scale human beings could not ever imagine a few decades ago. So implication of students, our future engineers and policymakers, the concept of digital twin and the way we'll be enshrined in this institution, especially in this school of civil engineering, will be shifting the way we learn. The way we learn is already moved by the impact of COVID. The combination of today's lecture is also an example of such, where you can integrate physical audience, as we see here, and virtual participants all over the world. So the implication is very obvious, and the drive for us to keep on with the digital twin application to enhance collaboration between various sectors, as well as communication across sectors, is very, very essential and form the framework of this professorship. So digital twin application with integration of system engineering, we have highlighted the importances and have been able to, in a nutshell, the way where some of our audience and non-technical audience will understand, we move forward within this number of years. I will be in Leeds to incorporate these knowledges we gained already in the industry in the area of digital twin, apply as we train our future engineers to be world-class engineers, starting with our infrastructure and few other development area of need. With this, I will be rounding up and see if I could take few questions from the audience. I can see the audience, both virtually and present, are really much. I'm not sure how many questions, if I'm not running out of time. Professor Prato, you help me if I don't know how many questions I'm allowed to answer within the time given. It's a very challenging part to go on and deliver a massive technology like a digital twin within the time frame of 1 hour. So I try to speak fast and get all these things and bring in a technical aspect of it and non-technical to speak in a way that I could communicate with my audience, because some of them might not be in a technical field. So if I'm still on time track, we stop here and acknowledge most of the people who made this professorship possible, ranging from University of Leeds School of Civil Engineering, the past head of school, Professor Bashir, the current head of school, Professor Prato, the supports gained by the academic, how do they call, how the Royal Academy called this? Academic champion, right? And Associate Professor Akin today, and very other support received by Royal Academy of Engineering. So I wish to acknowledge them for making this professorship and the cooperation between University of Leeds, P-Prime, Royal Academy, and University of Cambridge via Digital Twin Hub possible. Thank you all.
Thank you so much for your presentation. I will open up the floor for questions. And if you want to just to raise your hand, and if you are virtual or you want to write and I read it, it's completely up to you. Who wants to go first? Ashir?
Thanks, Paul, for that excellent presentation. It's a fantastic summary of various applications of a digital twin in civil engineering field, and you have brought in some specific projects as well as some possible way forward. So thank you very much for that. So my question is, when I look at digital twin and the whole area of Internet of Things and everything to do with them, I see the civil engineering academia, that is the undergraduate program in particular, shying away from introducing this in the curriculum. I mean, if I take the 24 Russell Group universities or even other non-Russell Group universities, I don't see that actually being integrated in the academic curriculum, particularly at undergraduate level. At postgraduate level, yes, there are some specific courses. So could you maybe elaborate on how can we integrate this type of concept in undergraduate curriculum? That's number one. Number two, our industry advisory committee chair, Dave Dovin, is very much a part of the Yorkshire Water, and I wish actually there is better interaction between yourself and him during your visiting professorship, because I see a huge potential for School of Civil Engineering to capitalize on your appointment as visiting professorship. So those are the two things. Thank you.
Okay, thank you so much, Professor Bashir. First of all, I'll take the first question first. There are two questions, 2 points you raised. One is how we could integrate digital twin in undergraduate level modules. And I understand that maybe some aspect of digital twin or system engineering is already integrated in postgraduate levels. So what I have in plan is this. I'm not sure the level of decision, but I would like, if possible, to sit in a technical committee. I'm not really conversant with the leadership right here in the school, whether it sits on faculty level. I will suggest the following. One, for most of the civil engineering, we start with this school. Take a look at some aspects of undergraduate modules that has to do with design, with engineering design, so that we can integrate digital twin and system engineering as part of existing module for a start. At some point, we move from that stage and start building up to form a full module that will be integrated in the school of civil engineering, as well as at some point blown up to application in various faculty applications. So that's the area I would like to look at what is existing. I've seen the water and wastewater module. We take a look at the existing module, because the University of Leeds is going to turn this to center of excellence if they get it right. Other schools will follow. In America, a few universities are already doing that. The way we learn engineering is automatically changing. The future application of digital twin in this module is very important, cannot be overemphasized, right? So these are the areas I would, throughout my tenure, look into. And when I meet yourself and Professor Prato, we think about how many modules we start with to integrate this. Then the second aspect is the application and forming a proposed a project that will integrate Yorkshire Waters, City of Leeds, and other stakeholders, using this school as the hub, and grow up that level of research and application to another level, inviting other bodies to form the hub within. Since the university is already established and have a global standard, a Russell Group of university, this can be done to be a game changer and lead other universities in this country towards the development of such skill sets. So I don't know whether the two sides of emphasis touch the area of you raised.
Yeah, thank you.
Yeah.
Yeah, and I think it's very interesting. I really enjoyed the discussion around the education. It is very important. We have an important appointment, which is 2024 for the accreditation of the civil engineering programs. And it's something that we should think more broadly. The university policy is going through this curriculum redefined, and we have actually committees that are looking at the curriculum. So I actually took note that could be a good idea to invite you to one of them for a discussion. But more broadly, and I will go back to the other question, and also Elena will be with you in a second. I just talked on this topic, Emilio, who is our Deputy Director of Student Education for the postgraduate, mentioning that perhaps there should be a thinking around a joint honors degree in civil engineering and data analytics, and something that we could consider. Of course, I noticed that Leeds is not the place where joint or double degrees, how I would call them to make it short, are really common, but this is the one area where everyone is talking about multidisciplinary approaches, so it could be also indeed a multidisciplinary approach in education. Thank you for the thoughts. And thank you, Emilio, for the comment. I will go now to Elaine, who had, and good to see you again, Elaine, after a while.
Yeah, nice to see you. Yes, the comment for that is I was head of School of Chemical and Process Engineering, but my whole life has been in data. Okay, so I have lived and I still live data. Data to me is just patterns. And that's where I want to come from. You mentioned at the end within your concluding marks about you collect, analyze, write data on an asset and determine what data adds value versus what does not. But I want to take a step back because I really quite like your comment on the fact that digital twins is only as good as the data from the actual process, asset, whatever word we want, area we want. I don't care whether it's civil, chemical, whatever the area is.
That's right.
Is this a limiting factor in terms of application and take up? And what can we start to do? Because we have sensors on, plants, etc. But how can we actually take that next step forward for it to be a much broader take up out externally because of the data aspect and the fact it is so reliant on that?
Okay, thank you so much. As you already pointed out, digital twin is just like any other simulator without data. Sensor that capture this quality of data is what makes a digital twin to deliver all those benefits I mentioned. So when we're talking about digital twin, we pay attention on data quality, because if you capture a wrong data, you do not get the quality of the data captured, cleaned, and applied, you are not going to get such results. All those results recorded, saving billions and other, is data. That is why I mentioned in the presentation that data is in its own right digital infrastructure. Is infrastructure that could be qualified in today's world to be gold. So for us to get it right, the designing of the digital twin in this institution, we first of all start with the module that will be used by students, designed by students, used by students for learning purposes, before we escalate to outside application. But the data quality, which we would like to collaborate with experts in data like yourself and others, we form very core aspects, important aspects of digital twin development and application. Starting from here, this school and other faculty that have interest, cutting across different disciplines. With the better, the more the better for us to develop this and make Leeds a center of excellence for this particular technology.
Yeah, because it's certainly something within obviously chemical engineering we're looking at. So to me, there's so much we talked about interdisciplinary degrees between this to me is around the digital side is such a strong and powerful one. But yeah, having somebody who's worked with data on processes from year dot to year today, it is such a massive issue. And I'll be quite blunt, I teach data analysis and I give the students just 25 variables. They're not, and it's real data from a plant. But I think it's that, we know what that quality is. And to me, it's how we start thinking in the real world to improve the data that we're collecting on the system. Are the data systems that we have really ready for this? Because it is so reliant. Sorry, I'll shut up because I think you can all gather. I love data. I could talk about data till the cows come home, so I'll stop. But thank you for a really interesting and provoking seminar.
Thank you.
Yeah, thank you once again. And like I said, we will be interested in collaborating with your team as well as we go on this journey, because a multidisciplinary approach is the best way to go about it. And it might interest you to understand that I started my career in chemical engineering, where I first started designing using simulators, those days by hand, solving the equations and developing different plans and designing. When we graduated to computer application, HISIS, Aspen Plus, this no longer the trouble we used to have. Now we're moving it to another level, a moving, mobile, virtual integration of all data, everything to get the job done. So we appreciate your own part, and we would like to collaborate with your expertise in the School of Process and Chemical Engineering.
Thank you.
Thank you so much. And in relation to this, I read from the chat because it's it's a take on the topic. Still staying on data flow leverage with our Deputy Director of Research and Innovation, among many other things that she does for the school. She's asking the question, how do you see the status of the data held by different infrastructure owners? And do you believe, Paul, that this is anywhere near sufficient to feed these types of models? And there is another aspect that is important. How would you tackle the issues of cost benefit in terms of data requirements?
Yes. What we do in digital twin in the real life is this. We first of all develop advanced data analytic as part of it, because digital twin is system of systems. When you come to a specific physical system, right, you take a look at how do you capture the data, and you build a hub, advanced data analytics. Artificial intelligence is part of its machine learning. That is a different field of learning on its own, but it powers the digital twin. Without the data captured by the sensor sent first to the parts that analyze this in advanced data analytic, you cannot get the quality you're going to witness in digital twin, right? So we integrate advanced data, machine learning, artificial intelligence, and all that as part of digital twin. So for us to make this possible, we are going to bring different aspects of research together and fuse it together. So this center I'm proposing, we have different expertise that we develop digital twin, bringing different expertise to the table for us to get it right and make it the global center of excellence.
Yeah, and it's very interesting, but I think what Fleur was interested also, there are a lot of data that the infrastructure owners have. I know, for example, I don't know if people know that TomTom, because I work in mobility and transportation, TomTom, the company that has navigation satellite systems, actually they sell data to transport engineers that do models, because actually every time the system in the car is updating, it downloads everywhere that the car went. Now, would be a number of questions about how really kosher that is, but that is for experts in ethics and legal today. But there is a lot of interest really in feeding data, to the point that there are quite a few companies that sell data as a byproduct of their work. And this, on the other hand, is very convenient for this type of work. We had a comment before also from Anne Valentur, who works in the circular economy for wind infrastructure research, and would be very interesting to see how these digital twins function. I think we have a couple of minutes. Is there any other question? Martin, you have the honor of closing.
Thanks, Carlo. Hi, Paul. Welcome to Leeds. I'm sorry that I can't be there with you physically to introduce myself today. I'm a member of staff in the School of Civil Engineering, but I also run a research centre called Water at Leeds in the university. So it would be great to get together and have a conversation with you at some point about how we can help, both to kind of like help you realise the interdisciplinarity aspects of what you're proposing, which I think are really exciting, but also how we can bring in some of the external kind of water-facing supply chain providers that you're keen to work with as well. I'm thinking about the likes of Yorkshire Water, Leeds City Council here. So it would be great to have a conversation with you about that at some point. My question, I think, you probably already answered it, but I mean, obviously one of the things about the water sector in the UK is that it's highly fragmented. And I see digital twins as being a fantastic opportunity to get fragmented industries such as the water industry, and perhaps even kind of more intersectoral facing utility industries working together in a more coherent way than they have done in the past, towards trying to kind of address challenges like net zero, that kind of thing. So I just wonder if you could just comment upon that, and how how realizable that kind of opportunity would be for, the likes of the water sector. Thanks.
Okay, thank you so much, Martin. The aspect of the water sectors in the UK, the challenge they have is similar to what some parts of infrastructure, other utilities are having as well. So the first thing we did when the National Infrastructure Commission beckoned in some of us in the industry around 2017 and start talking about how we form a national digital hub, right? Digital twin came into picture. We start talking about how do we share data. Some of these sectors, they don't communicate, they don't integrate properly. So first thing is to form a communication framework, form a policy behind how we can integrate and make different sectors to start talking to each other, have the trust on the use of the data, the quality of the information. Most of the information is commercial secret. So the framework is in place. We've contributed much to get this going. There's a lot of work to be done from April. From next month, we move to another stage of the talk. I'm moving it forward using what the National Infrastructure Commission called data for good, for the good of the people. Using under the government policy and regulatory framework, we believe at some point we'll come up with a policy, government policy that will help in integration of those water sectors and most of the companies and the vendors that participate in that sector. But this is a huge opportunity for us in Leeds to work together and capture the skill development aspect. And now it's put our foot on the ground and get this hub as a center of excellence I was proposing. So we discuss off record, like you said, one of these days I will sit down and have appointments with you. We discuss how to move it forward. A good work you're doing in Leeds Water, I know.
Brilliant. Thank you very much.
Yeah, thank you.
Thank you very much. I'm afraid there is can we get a quick one related from Nick Nikitas? Nick points out that we have an ability of modeling isolated components in a system. That part is really mature enough. Do you think, Paul, that will we be able also to consider the users that are rarely monitored adequately, and how could we cover for modeling what we call the soft part of the system? I have my own opinions based on my own research, actually. Yeah,
we have established in the industry, there are two ways we approach how to build a digital twin. Now we have advanced technologies, both radar technologies, different new technologies, digital technologies that we can use to capture and build a digital twin of a brownfield existing infrastructure. Then what we do at any stage of digital twin development, we need experts in modeling. Modeling forms important aspect. During the building of digital twin, we need experts in this area. During the application, the monitoring, the operation of the asset, we still need modeling because data doesn't work on their own. You keep writing code, modeling in a very advanced stage to get integration of advanced data analytical, artificial intelligence, machine learning into the digital twin to do the job. So the interface between modeling and other aspects is one of the key aspects of digital twin building, application, and delivery. So when we start the initial plan and application of this, we come up with already the framework developed by DNV, which we will follow for us to start the initial development here in Leeds. So modeling is typically part of it, integral part of the digital twin development and application.
Thank you very much. I would like to thank you again, Paul, for a very engaging lecture. You have seen that you have stimulated a lot of great questions, and I'm sure that there will be more opportunities for all of us to meet and have discussions around this very engaging topic. I thank you also the public that participated, and until next time, I bid you farewell and look forward to seeing you in person, Paul, soon.
Okay.
Thank you.
Thank you so much. Currently in Leeds, and I look forward to seeing you. We'll plan offline, and we take it up from there. And once again, I thank each and every one of you for your cooperation. I look forward to re-working with you in these years of my professorship at Leeds.
Thank you so much. Bye, everyone. Thank you for participating.
Thank you. Yeah, thank you. Thank you all for coming, and look forward to really working with all of you. Yeah, since you waited for a long time, you used to